Yeah, we should be live. Just talking to myself to check the sound and if there's any delay. Yeah, there's about 5, 6, 7, 8, 9 second delay, or less than that. Okay, I can't be counting it because when I'm talk in the video, it's me in the future. So if I count, anyway, there's 5, 6 second delay. You know what I mean? And so that should be fine, especially for talking to ourselves. So everything we do eventually appears on this website, biomedical.com. Go check it out. Your feedback is very important to us. Now, looking at this YouTube video about LLMs, everyone seemed to know a lot about LLMs. I don't think there's like a user manual for them, so I'm not sure how it works, but everyone is keen explaining how essentially something with how many dimensions, like with a billion of parameters, unless you do like a parameter reduction or something. I don't understand how you can explain something like that. But everyone is super keen explaining LLMs, how they work, what do they do, things like that. Well, pretty much everyone is keen explaining anything under the sun. There would be an expert for every single field. But as far as I can tell, there is no instruction manual for LLMs or humans. So it's a good model. And the original video had a very poor audio to it, so you could barely hear what the speakers are saying. That's the topic they were discussing, causal reasoning in large language models. And but the transcription in the video seemed to be correct. So obviously, as we do, we popped it into Notebook LM and got 17 minutes of a podcast about it. But then we decided to make a blog because we essentially want to put the audio on our website. I mean, we generated it. Yes, it was inspired by the video, but there's no copyright issues. But we asked Gemini, because Gemini meant to be better at this kind of stuff, to write a blog, but we don't like blogs like that only have text. So we are turning it into a more interactive web page, essentially like more like a web application where you can actually interact with the thing. And it's fairly simple. Yeah, AI that understands why. I think that's the topic was discussed in the video. Large language models are moving beyond blah 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 blah. Pattern recognition, grasp. Yeah, I have a classic example of correlation versus causation. You know, the ice cream sales and shark attacks. Yeah, and putting LLMs to the test, so you get the pairwise causal discovery. Then you have causal graph generation, so you have like rain, sprinkler, resulting wet grass. Okay, so this is a. Then we have coffee, heart disease, and the actual causes smoking. Confounder is a hidden variable. A counterfactual reasoning. A patient took medicine B and their condition was worsened. what if. And that doesn't make much sense. We had like a made up chart and calling it a day. But yeah, there's a couple of things we could improve. And the thing is, we could actually ask the robot that generated the blog, how could we improve, well, the text, but mainly the visuals on the page as we scroll, as the user scrolls the page. What happens if they actually don't press the button? Can we automate the animations as we are scrolling as well, and keeping the buttons in place as well? So that will be for all the 4 examples: the causal discovery, graph generation, confounders, counterfactual reasoning, and also say for the first graph, the correlation versus causation. So the hidden cause summer hit could be displayed as we scroll the page as well, or click on the graph perhaps, and it could be just overlaid on top of the graph in red or something, so it's clearer in bold red. So can we make the changes to the code? If you have any other suggestions how to change the code, make the web app blog more interactive and clearer, do let me know. We might need more text as well. Don't be shy. Any dark humor or jokes are welcome too. Yeah. Oops. The speech to text is making mistakes, but me typing doesn't make things much better, does it?
Welcome to the deep dive. Get ready, because today we're plunging into something really fascinating. The surprising place where cutting-edge AI meets one of humanity's oldest puzzles, figuring out cause and effect.
That's right. We're digging into some, well, really interesting work. It's based on a presentation and a paper involving researchers, including some from Microsoft, looking at how large language models, LLMs, are starting to tackle the incredibly complex world of causal reasoning.
And our mission here really is pretty simple: to unpack what they found. How are these massive AI models being used to grapple with that fundamental challenge, pinning down the why behind things we observe?
Because, we've all heard the old saying, correlation doesn't equal causation. It's like drilled into anyone doing science or even just trying to make sense of the news.
Absolutely. So the big question this work gets into is, can an AI actually, learn to tell the difference?
Let's unpack this. The core problem they highlight is, well, it sounds straightforward, but it's profoundly difficult in practice, just because 2 things happen at the same time. Or maybe they seem to increase or decrease together doesn't automatically mean one caused the other.
It sounds so obvious, but it trips us up constantly. Think about those classic examples they bring up in the material. You see a spike in shark attacks, and at the exact same time, ice cream sales just go through the roof.
Perfect correlation. But thankfully, ice cream isn't actually luring sharks.
Right, it's the shared cause, the underlying thing. Summertime. Warm weather sends more people to the beach, more potential interactions with sharks, and also makes everyone crave ice cream. Simple.
Or remember that study from years ago about nightlights and myopia in children?
Oh yeah, I remember that one.
Initially, it looked like kids who slept with a nightlight were, more likely to become nearsighted.
Which is a pretty scary thought if you're a parent.
Totally. But as later research showed that the guy discussed here, there was a common cause at play there too. Parents who are myopic themselves, they tend to use nightlights more often.
Oh.
Maybe they read later or work, needing the light. And myopia often has a genetic component. So the myopic parents pass on the genes and use the nightlight, creating that correlation in their kids without the light itself causing it.
They even bring it right up to today, looking at examples from the COVID era. Sometimes analysis of CT scans trying to detect COVID actually ended up picking up on, well, other things like patient position or age.
Exactly.
Yeah.
It wasn't the scanner really measuring COVID symptoms directly as much as reflecting hospital protocols. Very weak patients might be made to lie down, that's position.
Right.
Or children were less likely to have severe COVID than adults, that's age. These factors correlated with whether someone was likely to have severe COVID, and so the scanner output correlated with them, but it wasn't isolating the disease itself.
So what all these examples examples really hammer home is that historically, untangling these messy relationships, figuring out the true causal arrow, well, that required deep human expertise.
Yeah, you needed a doctor, a biologist, maybe a physicist, a sociologist, someone with real specific knowledge about the domain to reason through the possibilities.
And that gets right to the heart of the challenge for AI, doesn't it? Working with causality, especially trying to build these things called causal graphs.
Yeah, complex maps showing how many different variables influence each other.
That's been a huge hurdle for machine learning models.
And they highlight two main difficulties here. One is that, frankly, human experts are still better, particularly with really complicated sets of variables or trying to pull causal information directly from unstructured text, think scientific papers, doctor's notes, that kind of thing.
Makes sense.
The other thing is that even these really powerful models like LLMs, they can still make unpredictable errors. They don't always reason the way we do.
Which is why the goal this work sets out isn't really about replacing human experts, is it?
No, not at all. It's more about combining LLMs with existing rigorous causal methods to potentially speed up and enhance causal analysis across all sorts of scientific fields. Think of it like giving experts a powerful new assistant.
Okay, so how do they actually start testing if LLMs could handle these causal tasks? Where do they begin?
They began by looking at something simpler, pairwise relationships.
Yeah.
Just two variables, A and B. Can the LLM figure out if A causes B, or if B causes A, or maybe neither?
Right, the basic building block.
Exactly. They use a specific set of tests, the pairwise relation distribution benchmark. It has over 100 pairs of variables from incredibly diverse areas, everything from biology to engineering.
And they tried different ways of asking the LLM.
Yeah, like asking, does A cause B in one go? Or maybe breaking it down into separate questions like, does A cause B and then does B cause A?
Yeah.
Trying different prompts.
Okay, and the results. This is the interesting part.
Yeah, here's where it gets really interesting. When they put GPT-4 to the test on this specific benchmark, it achieved an accuracy of 97%.
97% on just figuring out the causal direction between two things across all those different fields.
Yep.
Wow, that seems dramatically higher than previous models. Weren't they around 83% or something?
That's right. The previous best data-driven models were at 83%. And this really highlights a key distinction they bring up in the work.
Which is?
Well, those older data-driven methods would look at large data sets of actual measurements, like paired numbers for altitude and temperature readings, and try to infer the directionality purely from the patterns in the data itself.
Right, like noticing higher altitude generally means lower temperature, so you infer the likely cause from that numerical pattern.
Exactly. But these LLMs, which they describe here as knowledge-based, seem to be doing something, well, different. They appear to be tapping into the vast amount of text they were trained on.
So the stuff they read.
Yeah, information about how the world works that's just embedded in billions of sentences. They describe it almost like fact remembering or retrieval. It seems less about crunching the numbers in front of it and more about accessing this huge store of background knowledge.
That is kind of mind-blowing. It suggests they've somehow absorbed some fundamental understanding of causal relationships just from reading the internet, basically.
It does seem that way, at least for these pairwise tasks. But, figuring out the relationship between just two variables is one thing. The real beast is what they call full causal graph recovery.
Mapping out all the connections when you have many, many variables interacting.
Precisely. And trying to do that just by combining all the pairwise results. That can lead to really messy, overly dense graphs. They mentioned one research project where this actually happened. Suddenly, everything seemed to cause everything else, which is very helpful.
Yeah, sounds like noise.
Right. Recovering those full, sparse, accurate graphs requires much more sophisticated techniques. And it often relies on big assumptions, like something called causal sufficiency.
Causal sufficiency. What's that again?
It basically means assuming there isn't some unmeasured outside factor influencing multiple variables in your graph that you don't know about, which could be messing up your analysis.
Assuming you've got all the important players accounted for.
Essentially, yes.
Right.
And it just makes you appreciate how hard this has been historically. Even figuring out the directionality between just two variables using pure statistics was incredibly tough back in the day. It took some really, as they put it, ingenious ideas from researchers years ago to overcome those limitations long before we had these massive data sets or these powerful LLMs.
Okay, so 97% accuracy on pairwise is amazing, but it's not 100%. Where are these LLMs still stumbling? What makes up that roughly 3% error rate?
Well, they point to issues with what they call ambiguous features. Basically, the LLM can get confused by vague language in the input prompt.
Can you give an example?
Sure, like asking about ozone concentration and radiation. You might get a wrong answer initially, but if you clarify it to ground-level ozone concentration, which has a known relationship, then it gets it right.
So you need to be really precise with your prompts sometimes. It's not magic.
Exactly. It might even take a few tries, refining the question, which they noted was a bit surprising to some. You can't just ask one vague thing and expect perfect causal reasoning every time.
It sounds like that initial response, if the input's fuzzy, might be more like the LLM pulling a sort of stereotype from its training data, rather than truly reasoning about the specific situation.
That seems to be the idea, yeah. It defaults to common patterns. It's seen if the query isn't specific enough.
Okay, what about novel data? Information the LLM definitely hasn't seen during its training. Can it still figure out causal relationships in that context?
That's a great question, and they tested this. They used a data set focused on neuropathic pain. And the prompt wasn't just a list of variables. It included details, even tables of data, describing things like left C3 radiculopathy or right adductor tendonitis, sometimes with known relationships already mixed in.
So the LLM had to use its general background knowledge plus this specific new data provided right there in the prompt.
Exactly. It had to integrate both.
And the results there?
Again, remarkably high on this specific novel dataset GPT-4, got near 97% accuracy again,
Wow.
which suggests they can actually integrate new information provided in the prompt with their existing knowledge base, at least for this kind of causal inference task.
Okay, that's impressive for reasoning. But they also tested its ability to use novel data for other tasks, right? Like just recalling information from new tables.
They did, like
Yeah.
filling in empty cells and tables containing information it hadn't seen before.
Mhm.
I think there was a data set about tubing manufacturing or something.
And how did it do there?
Well, the accuracy dropped significantly, something like 61% accuracy for filling individual cells correctly, and only 25% for getting a whole row right.
Mm.
So this tells us that while they can process and integrate novel data for causal inference pretty well, tasks like precise data retrieval or table completion based only on that novel data, well, those still present challenges. It's not a perfect recall machine just for new inputs presented that way.
Okay, so thinking about all the successes, the struggles, how can we actually start putting LLMs to work in the world of causal analysis? What are the practical applications?
They suggest several ways LLMs can assist human experts. One big idea is generating candidate causal graphs.
So not the final answer, but possibilities.
Exactly. Not graphs you blindly trust, but potential structures, maybe hypotheses, for a human expert to then review, validate, modify, or even discard.
Kind of like brainstorming for complex problems, but with an AI partner.
Precisely. They could also potentially critique existing graphs that a human has drawn, maybe spotting a connection the expert missed, or suggesting a missing variable, a potential confounder.
And I could see them being really helpful in the early stages of designing a study, right? Like you feed it your proposed variables.
Yeah, and it might suggest potential confounders you need to control for those variables that confuse the issue by influencing both your supposed cause and effect.
Or maybe suggest instrumental variables, those clever variables that can help isolate the true effect you're interested in.
That's another possibility they mentioned. And this is a really critical point, they emphasize repeatedly, human validation is absolutely essential, especially in high-stakes situations.
You mean like
Sensitive psychological cases or critical engineering systems or medical diagnoses. You don't just let the AI make the final call.
So it's about augmentation, not automation, at least for now and probably for a while in complex fields.
Definitely. And they make the point that even human experts don't always know everything. So combining their deep domain knowledge with the LLMs, let's say, vast pattern matching and knowledge retrieval capabilities seems like the most promising path forward.
Interesting. They mentioned something about a Python library too.
Oh yeah, that was a nice touch.
Yeah.
They mentioned the development of a Python library specifically for doing text-based causal analysis. It's kind of an homage to Judeo Pearl's foundational work in the Book of Why,
Mhm.
which is, a landmark text in causal inference.
Very cool. Now, speaking of foundational concepts, the work also looks at whether LLMs can handle some key causal primitives, like the basic building blocks of causal reasoning itself.
Right, like understanding different types of causality. Can it distinguish between, say, population-level causality?
Like, does smoking cause cancer in general?
Exactly. Versus the actual cause for a single specific event. Did smoking cause this specific person's cancer? Which is a much harder question.
Or handling causal context, knowing that a cause might only lead to an effect under certain conditions, and distinguishing between necessary causes and sufficient causes.
Yeah, and the logic gate analogy they use is actually really helpful here. Think about an AND gate in electronics.
Yeah.
You need both input A and input B to be true for the output to be true. So A is necessary.
Yeah, we love electronics examples, but yeah, I was trying to stick to medical, biomedical data, but mainly we'll also improve this board. We have now 12 minutes on it. Just on the development side of things. Anyhow, there is a human in the loop. If you have any questions, do let me know. I probably won't be able to answer it myself. I'll use it as a prompt. We can answer it together.
Okay, let's unpack this. Welcome to a new deep dive. Today, we're plunging into a really fascinating space, the world of figuring out why things happen. The heart of causality and causal inference.
Yeah, and how that whole field intersects with, well, the pretty rapidly evolving capabilities of large language models, LLMs.
It's quite a collision, isn't it? Two really important areas.
It is, and our material for this deep dive, it comes from a video presentation by Salim Suleymanoglu. He's discussing research that asks this core question. Can LLMs actually help us tackle the really tough problems in causal inference?
Exactly. So Our mission, let's say, for this dive is to really understand what causality truly means, how it's, fundamentally different from just seeing two things happen together, correlation,
Right.
and why figuring out that true why has, well, always been such a challenge.
Hmm.
And then look at the surprising ways LLMs are starting to assist. But also, we need to be really clear on where human expertise, remains absolutely essential.
Definitely. And to ground this right away, and really show you the difference between correlation and causality, the presentation kicks off with that classic, super easy to grasp example. Think about those hot summer days, right?
Yeah.
You see headlines, maybe, about more shark attacks.
Okay.
And around the same time, you also see reports of, well, more ice cream sales.
Right. Sun's out, beaches are packed, everyone wants ice cream. Makes sense.
Yeah.
So the immediate question is, wait, is eating ice cream somehow causing the shark attack?
Or the other way around. Do
Yeah.
shark attacks make people suddenly crave a cone?
Yeah, exactly. It sounds
Okay, wait a sec. Having trouble. Okay, so the web page says that the buttons replay the animations, but no, that doesn't seem to be the case. Maybe you can explain. Also, can we activate the animation if the user is scrolling? Essentially, if the animation is at if the item is at half the screen or near half of the screen when scrolling, we can then start the animation. Otherwise, we want them to be able to press the button. Also, as the text suggests, the button should still work and should replay the animation if the user presses on it again. Do you know what I'm talking about?
sounds absurd when you say it like that.
Right. And what's fascinating and really crucial here is that while shark attacks and ice cream sales are definitely correlated, they move together, they go up and down together, neither one is causing the other.
Okay.
They actually share a common cause.
Okay.
Hot weather. Simple as that. The heat drives more people to the beach, potential shark territory, and it also drives up demand for ice cream.
Got it. So the third factor, the heat, is the real driver.
Precisely. It's the perfect illustration. Just because two things happen together doesn't mean one caused the other. Correlation is not causation.
Absolutely. And that simple idea, it just scales up to incredibly complex problems in, well, almost every field you can think of. Medicine, economics, social science, climate.
Everywhere.
Yeah. Figuring out the real causal links, the true why, is just incredibly hard. Why is it so tough traditionally?
Well, traditionally, it demands really deep domain expertise, for one.
Okay.
It often requires specialized statistical methods or even experimental setups, and you're often dealing with messy or incomplete data, right?
Right.
Or those tricky confounding factors, hidden variables that influence both the supposed cause and the effect.
Like the hot weather example.
Exactly.
Yeah.
Or you just face situations where you simply can't run a clean, controlled experiment in the real world. You can't randomly assign certain things to people or situations.
Sure. That makes sense.
So that difficulty has always made causal inference a really challenging, expert-driven process, especially when you're trying to pull insights from rich but, unstructured information like text.
Okay, so that brings up the big question then. Where does a tool like an LLM, which is like famously good at processing text, fit into this whole complex picture?
Well, that's what the research explores, and it highlights some really intriguing capabilities these models are starting to show.
Such as?
For one, they're getting surprisingly good, it seems, at identifying potential causal connections directly from text itself.
Okay, how does that work?
Well, the video explains that LLMs are becoming more adept at looking at sentences, paragraphs, even, longer documents, and starting to pick out relationships that seem to imply cause and effect. Not just simple association, but actual causalities. Like, they've seen so much text describing events and their consequences that they start recognizing the linguistic patterns that signal A causes B.
Interesting. So it's pattern recognition on a massive scale applied to cause-effect language.
Kind of, yeah. And beyond just spotting those links, the research gets into another really fascinating capability. their ability to reason about counterfactuals.
Counterfactuals. Okay, that's the what if question, right?
Exactly. What if this specific thing hadn't happened? Would the outcome have been different? It's like thinking about alternative realities based on changing one potential cause.
Which is something humans do all the time when we reason about why something happened.
Absolutely. It's core to how we understand causality. We don't just see what did happen, we mentally simulate what might have happened otherwise.
Yeah.
And the paper explores how LLMs can actually perform this type of counterfactual reasoning, how they can simulate these alternative outcomes based on the text they analyze.
Okay, that's pretty sophisticated. And it's not just simple A causes B stuff either.
No, not limited to that. The research looks at how LLMs can handle different levels of complexity when it comes to the causal assumptions you feed them. So everything from spotting those simple pairwise links up to trying to recover a much more complex full causal graph, showing how lots of different variables might be influencing each other.
A whole web of causes and effects.
Pretty much. And what's interesting is how they deal with ambiguity, because text is full of it.
Oh, definitely. Language is rarely perfectly precise.
Exactly. So the research points out that text often leaves room for interpretation. And it shows that giving the LLM more context significantly improves its performance. Helps it, more accurately identify these causal links and structures when the language is a bit vague.
Right. More context helps disambiguate.
Mm.
Okay, so they can potentially identify links, reason about what ifs, handle complex structures from text. How are people actually using these capabilities? Like, what are the practical applications being explored?
Yeah, good question. A really significant application discussed is using LLMs to assist human experts in the causal inference process. It's more collaborative.
How's-
Well, for example, you could prompt an LLM to generate an initial causal graph, maybe based on information it extracts from a pile of research papers or domain literature.
Okay, like a first draft of the causal map.
Exactly. Or it could even be used to critique or suggest modifications to a graph that an expert has already put together.
Interesting. Like a knowledgeable brainstorming partner.
Sort of, yeah. It's not replacing the expert's thinking, but it's giving them maybe a powerful starting point or a different perspective that's drawn from analyzing vast amounts of text data.
Right.
Okay. Obviously, it likes talking a lot, and that's great. We also like to chat. There's a couple weird things about this thing. I mean, that's pretty good. I don't know if we need. It's always reverting using Google stuff, obviously. Bum, bum, bum. So obviously, I mean, we can finish it in with GitHub Copilot, can we? Let's actually try it out, because I think Google will be still biased towards using some of these tools. So we have it now on running locally on a server. By the way, there is a human in the loop, so if you have any questions, go for it. Just a simple GPT-4o. Do we actually have to use Tailwind CSS, or can we have a custom CSS for the page? I'm actually more inclined to just removing Tailwind and removing any current styling and then redoing it from scratch. Well, because we also have... it wouldn't let me finish. The bot is very
You don't
keen
have
on
to use
responding.
Tailwind CSS. You can absolutely remove it and create custom CSS for the page. Tailwind is a utility-first framework that simplifies.
Okay, yeah. Okay, so can we remove Tailwind and potentially redo the whole styling from scratch, like within the page, without any external resources? I mean, we could also remove the Google APIs, the fonts, just keep the chat.js. Does that make sense? Let's see what happens.
Made
not talking.
changes.
Made changes. Okay, it seemed to have worked. We're doing vibe coding, so none of that. You got okay, you got rid of too many things, didn't you? Now we want 521 lines back, and we probably use a different model for that, because obviously GPT-4o was not able to handle it. Let's do, I don't know, is it too hard of a request? Let's do Claude 3.7 Sonnet Thinking. A human who wants to join in the conversation, you're always welcome. Well, especially if you checked out. So everything we do eventually goes on this website, bionichaos.com. So go check it out. Let me know what you think. One of the last tools to be, Gemini Ed. Okay, this tool was brought to you by Gemini. Well, literally, it was made by Gemini. But we'll hide the ads for now. Yeah, it's a synthetic noise generator dashboard. Go check it out. You can select your noise type, a number of samples, sampling rate. Yeah, it becomes slower as the sampling rate increasing. You can regenerate as many times you want. You can also export it as CSV. How good is that? Everyone is keen on exporting stuff. The periodic noise there, you have this custom periodic noise where you can actually change each one of the components. So expect the frequency 2 to move to the right. Yes, it did. You can make it what you like. You can make it what you like, and will generate the noise. But yeah, there's like a preset example for it. And then most importantly, it has pink and brown noise. And the reason it's interesting for us is because it looks a lot like baseline EEG. How good is that? Yeah, most of the recording, especially made using whatever consumer EEG devices, you know, the toys used for gaming and stuff, you're mostly recording noise anyway. So you might as well, you know, use the noise generator to do your stuff. And yes, you could analyze the data and get some meaningful results out of noise, because there's a lot of interesting things in noise, isn't there? And so this one allows you, oh, you can change the sample size. If you reduce the sampling rate, increase the number of samples, then you can get whatever 100 seconds worth of data, potentially 400 seconds worth of data if you reduce the sampling rate. Otherwise, this thing, it's already taking 200 megabytes in your browser. So yeah, you can change your frequency axis from linear to logarithmic. Logarithmic is default because it just looks better. We can do the same for the power axis, but it doesn't change much. It just changes the y-axis there. It actually recalculates the thing. But anyhow, and there is auto scaling. So yes, if you, just play around with it and let me know what you think. And we're generating another thing, and from memory, Claude made some mistakes. Oh, it's still thinking forever. Claude 3.7 Sonnet thinking forever. Might go grab a coffee while it's thinking. Might go grab a coffee. Thinking for too long. And yes, there is, as you can hear, I'm not a robot. Well, how would you know? You wouldn't know, would you? There is a human in the loop that does vibe coding. So not reading any of the code, but just testing it straight away. What's that? What on earth? Okay, maybe we did need the tailwind in there. Let's clear the console, reload the page. Mueller. Okay, stuffed a few things out, didn't you? Well, it's not good enough because just because it's not good enough. Let's go back. What's happening? How long was the code? 521. That's right. Did you stuff up my code? That's not nice. You're not nice at all to me today. You made a lot of changes, stuffed up my page. Am I supposed to say thank you for that? No. We would not be thanking you for that. Okay. 521 should be it. Okay. No, wait, that's 501. 521. Yep, should still work. Clear console. Yeah, that works. We have the tailwind. Okay, let's do things one by one. Or should we just leave it with the tailwind? I can't be bothered, really. I mean, it's good enough. We can still deploy. We'll be having that weird do not use in production. Okay, this is a prototype tool, so we can handle warnings like that. This should be fine. We could do a deep dive on it with a Gemini, a deep research or whatever. Add another document. It could be like a PDF at the bottom of a deep research on the topic. Should we bother? No, I don't think so. Let's just turn it into a podcast with these guys. This podcast is more about like the development process. It's essentially everything we have been doing to make the application. So this application, we have it running locally as well. We generated a bunch of podcasts. We had the original one on the video that inspired this application. So thank you very much to YouTube video. Then we generate this blog post. We actually do have a a drier blog on this, but no one cares. You can go regenerate one of your own. It will be custom to you. I'm also running an experiment on this YouTube channel. What's better, me talking or AI talking? What gets more traffic or engagement? And I'm not sure which one is which. Well, currently there's no questions in the chat, so might as well let the bots finish talking.
Right, helping the expert build and refine their causal models more efficiently. That makes sense.
The paper also mentions their potential to help fill in missing data within data sets used for causal analysis.
Well, that's a huge practical problem. Missing data is everywhere.
It really is. And building on that counterfactual reasoning we mentioned, they can be used in simulations too. Once you have a potential causal model, you can leverage the LLM's text-based understanding to explore different what-if scenarios.
So predicting outcomes under various hypothetical interventions based on what the text suggests.
Exactly, based on the textual evidence it has processed.
Wow. It's clearly moving beyond just theory then.
Seems like it. There's even mention of a specific Python library being developed for this exact purpose. I think it was called PyLLM.
PyLLM. Okay.
Yeah, suggesting this integration of LLMs into actual causal analysis workflows is, actively happening. People are building tools.
Right. Which leads to the obvious next question.
How well do they actually work?
Yeah, how good are they?
Yeah.
What did the benchmarks show?
Well, the research presents some benchmarks that are quite striking, actually.
Okay, this is where it gets really interesting.
They ran tests on various causal tasks derived from text, and the results included findings about models like GPT-4.
Don't leave us hanging.
And while GPT-4 showed high accuracy in these text-based causal inference tasks.
High accuracy. Okay, that's impressive on its own.
It is noteworthy, yeah. But what's perhaps even more surprising, as the research highlights, is that in some cases, GPT-4 actually outperformed traditional statistical models.
Wait, hold on. Outperformed models specifically designed for certain causal tasks.
In certain specific benchmark tasks, yes, that's what they found.
A general-purpose language model,
Yeah.
mostly trained on, predicting the next word. Sometimes doing better than specialized tools built over decades for causal analysis. That's pretty significant.
It is. It really underscores how much complex reasoning ability seems to be, latent or emergent in these large models.
Wow.
And it wasn't just that. The research also found improvements in counterfactual reasoning tasks when using these models compared to human annotators in certain benchmarks.
Better than humans on some what-if tasks.
Again, not across the board, but specific instances where the model showed surprisingly strong performance compared to the human baseline they used.
Okay, that's a really powerful set of new capabilities and some eyebrow-raising performance results. But this brings us back to that absolutely crucial point the research emphasizes, right? Especially in the concluding thoughts. What does all this mean for the human expert, the person who's traditionally owned this field? Are they out of a job?
No, not at all. And that's the core message, really. While LLMs bring these powerful
They're
new
so
abilities
out of the
like
job.
tapping into vast, diffuse domain knowledge embedded in text in a
keep
way traditional
convincing
methods
yourself.
maybe can't,
Mm-hmm.
and enabling these new types of causal analysis directly from unstructured text, the paper is very, very clear. Human experts remain vital. Irreplaceable, really, components of rigorous causal analysis.
So it's not a story of replacement, it's augmentation.
Exactly.
Well, I got a PhD and this thing can replace me, tomorrow. Yesterday. So good luck.
Augmentation is the right word. LLMs can be incredible assistants for generating hypotheses, maybe drafting initial models, extracting relevant info, running simulations, that kind of thing.
Right, the heavy lifting maybe, or the initial exploration.
Yeah. But for validating those outputs, applying critical thinking, understanding the deep nuances of the domain, designing proper studies, and crucially, making high-stakes decisions based on causal conclusions, human judgment is absolutely...
Well, you only require human because of legal reasons, but no, those models can make judgments way better than humans can. The error rate will be way smaller, don't you think?
absolutely essential.
Especially when the consequences of getting it wrong are significant, like in medicine or policymaking.
Precisely. You need that human oversight, the skepticism, the deep contextual understanding to ensure the analysis is sound, trustworthy, and, well, responsible.
Okay. So wrapping this up then, what does this all mean for you listening to this deep dive? I mean, whether you're in business trying to understand customer churn or marketing impact.
Or science, trying to understand a system failure, or maybe how a policy change affects behavior.
Yeah, understanding the why behind the data is just fundamental to making good decisions, isn't it?
Absolutely. And these new tools, powered by LLMs, they aren't just theoretical anymore. They're starting to change how we can approach that challenge, maybe making it faster or possible in new ways from text data.
But always, it seems, in collaboration with human insight and expertise.
That seems to be the key takeaway. It's a partnership.
Okay. So, to leave you with a final thought to maybe mull over.
If LLMs can increasingly reason about cause and effect and even simulate alternative histories, by exploring these counterfactuals from all the texts they've learned from, how might this fundamentally change how we analyze the past, or understand the present, or even plan for the future?
Right. What new questions does this raise? Maybe ethical, philosophical ones?
Yeah, about the nature of automated reasoning, about decision support, especially when a machine can effectively start saying, well, if X hadn't happened, Y likely wouldn't have either, based on everything we've read.
That's definitely something to think about. A powerful and maybe slightly unsettling capability.
Yeah, that's right. That is correct. Okay, so we get the tool. We also want to generate. Okay, couple of things. Well, first of all, let's do a new chat. Ideally, we'll have the. Well, ideally, we would have gave it the page, the URL, but the text will suffice in this case, wouldn't it? And just the text base only. Let's generate another thing. Yeah, I want to get rid of the we want to get rid of the troubleshooting on the page. And let's give it to and let's set it to the chat quickly. And let's just do, are there new models? Looks like. No. Of 1 or 3. No, it's the same. Which one's default? Let's do GPT-4o. It's the quickest one. Oh, they did change it. They did change it. agent mode. Okay, we haven't actually read the release notes or anything, well, because they are long and boring, but obviously GitHub Copilot made some changes. Now we don't have 2 tabs anymore, we just have the one, which is kind of makes sense. But then I got kind of used to the 2 tabs. You can select your model. As before, you have Claude 3.5, 3.7, 3.7 thinking, and the new Sonnet 4. I think before it said preview, now it's supposedly fully deployed. Is it? Used to be super slow. Let's try it out. Best thing we can do is just try it out. Let's make this bigger. We're not editing. Can you just give a summary of this code, what this application, web application is all about? And also, can you find any issues with the code at the moment? Obviously, you have some ideas in mind. Here, Claude Sonnet 4
Summary.
is super
This
slow.
is an
Now it's much
interactive
faster.
single-page web application about causality and large language models that explores how AI is moving beyond pattern recognition to understand cause and effect relationships. What the application does: educational demo, teaches the difference between correlation and causation through interactive visualizations. LLM capabilities showcase, demonstrates how large language models can perform causal reasoning tasks like pairwise causal discovery, determining direction of causation between variables, causal graph generation, identifying confounding variables, counterfactual reasoning, what-if scenarios, performance comparison, shows benchmarking data comparing LLMs versus traditional models. Human-AI collaboration, concludes with the vision of experts working alongside AI. Technical features, built with vanilla JavaScript, Tailwind CSS, and Chart.js. Scroll-triggered animations using Intersection Observer, interactive charts and dynamic visualizations, responsive design with custom CSS animations. Issues found: 1. Missing HTML elements. The JavaScript references elements that don't exist in the HTML. Missing from confounder demo HTML. Div ID equals node C class equals node, coffee/div. Div ID equals node HD class equals node, heart disease/div2. Animation state management. The demo state tracking could cause issues if users scroll quickly or interact before animations complete. 3. Error handling. Limited error handling for chart rendering failures or missing DOM elements during animations. 4. Performance concerns. Multiple set timeout chains could cause timing issues. No cleanup for intersection observers. Arrow creation doesn't check for existing arrows before creating new ones. 5. Accessibility issues. No ARIA labels for interactive charts.
Okay, let's dive right in.
Yeah, let's do it.
Today we're looking at something pretty cutting edge, causal AI.
And specifically, the new role that large language models seem to be playing in it. It's quite a shift.
So our goal here, for you listening, is to really unpack how AI might be moving beyond just, seeing patterns.
Right, beyond correlation, towards understanding why things actually happen. That's the causation piece. And it's much harder.
And the potential there is just huge, isn't it? Like changing science, how we make decisions.
Oh, absolutely. So we've gone through the source material to pull out the key bits, the examples, give you kind of shortcut to what's going on.
Great. So where do we start? The classic problem.
Exactly. Correlation versus causation. It's like the foundational concept you have to grasp, and where so many mistakes are made with data.
Yeah, I see that all the time. The source had a good, simple example, right? Ice cream and sunscreen.
Perfect one. Data shows ice cream sales go up, sunscreen sales go up. They trend together. Strong correlation.
But buying that cone doesn't make you buy sunscreen.
No way. The source jokes about it like, It's the SEN, you silly goose.
Right.
The hidden cause, the confounder. It's just the summer heat. Heat drives both ice cream buying and sunscreen use.
So correlation definitely isn't causation. A crucial reminder.
Always.
Okay, so if that's the pitfall, how are these LLMs actually starting to, do causal reasoning? What can they tackle?
Well, the sources show them being tested on specific causal tasks. One is called pairwise causal discovery.
Okay.
That's looking at just two things, two variables like education level and annual income, and the LLM tries to figure out the direction. Does education likely cause income changes or the other way around?
So figuring out the arrow's direction. A causes B or B causes A.
Exactly. That's a basic building block.
Mm-hmm.
Then they can scale up to causal graph generation.
More complex.
Yeah, mapping out how multiple things might be linked. The source used the example of rain and a sprinkler, both potentially causing wet grass. You build a whole model, a network.
Kind of like drawing the whole system of why. What about finding those silly geese, the confounders?
That's another key task.
Yeah.
Identifying confounders. Remember the heat example. Or another one mentioned is coffee and heart disease. They often correlate.
Mm-hmm.
But an LLM might help spot that, wait, maybe smoking is the confounder here. People who smoke might also drink more coffee, and smoking raises heart disease risk. So the coffee link itself could be misleading.
Got it. Finding that hidden variable that's sort of muddying the waters.
Precisely. And the last one they mentioned is really interesting, counterfactual reasoning.
Sounds like sci-fi. What ifs?
Basically, yeah. Predicting alternative outcomes. The source gave a medical example. If a patient got worse on medicine B, could the AI estimate what might have happened if they'd taken medicine A instead, based on all the causal factors?
Wow. Okay, that's powerful. Testing hypotheses without needing a full real-world trial every single time.
That's the idea. And it's not just theory. The sources point out that on standardized causal benchmark tests, these LLMs are actually significantly outperforming older methods.
Really? Better than tools designed for this?
Seems so. It suggests they might have some kind of inherent grasp of causal relationships learned from all that text and data they trained on.
But the sources aren't saying the AI just takes over everything, right? It's more about teamwork.
Definitely not taking over. It's framed very clearly as human-AI collaboration, a synergy.
Okay, so what's the human role in that picture?
The human expert asks the critical questions, brings the deep domain knowledge, the real-world context, makes ethical judgments, interprets the findings, the stuff AI can't do.
And the AI?
The causal LLM is like the accelerator. It crunches the massive data, flags potential confounders we might miss, generates hypotheses way faster, does the analytical grunt work.
So humans guide, AI assists and scales up the analysis.
Exactly. The vision is accelerating discovery, tackling problems that were just too complex or data-heavy before.
It really paints a picture of a future where we can get closer to the real root causes of things by working with these tools.
Yeah, and when you think about data you see every day, understanding why is just so much more powerful than just knowing what is happening together. It lets you actually intervene effectively.
Makes sense.
It allows for real change.
So bringing it back to you listening, if AI really can help us understand the true causes behind really complex issues, societal problems, scientific mysteries, whatever it might be, that leaves us with a pretty big thought, doesn't it? What massive, long-standing problems might this kind of human-AI partnership finally help us solve? Something to think about.
Okay, we actually have the new agent within Visual Studio Code doing some work. So it's Claude Sonnet 4. It's having access to all these tools. Can create a workspace, can pretty much do anything. Git, search Git, I would assume, find updates. And it's already made 38 changes to the code.
B is necessary, but neither one is sufficient on its own.
Index.html. Add a color property to the .node class to ensure text inside the boxes is visible. Index.html. Adjust the .node class to use a darker text color for better visibility against the bright background.
Okay, so we have Gemini 2.5 Pro acting as an agent, has access to all these tools, code base and everything, can create new workspaces and what's not. So we'll let it do its job. Should be like an equivalent of a senior developer. Okay, did it actually stopped working or what?
Okay, let's dive right in.
Yeah, let's do it.
Today we're looking at something pretty cutting edge, causal AI.
And specifically, The new role that large language models seem to be playing in it, it's quite a shift.
So our goal here for you listening is to really unpack how AI might be moving beyond just, seeing patterns.
Right, beyond correlation, towards understanding why things actually happen. That's the causation piece. And it's much harder.
And the potential there is just huge, isn't it? Like changing science, how we make decisions.
Oh, absolutely. So we've gone through the source material to pull out the key bits, the examples, give you kind of shortcut to what's going on.
Great. So where do we start? The classic problem.
Exactly. Correlation versus causation. It's like the foundational concept you have to grasp, and where so many mistakes are made with data.
Yeah, I see that all the time. The source had a good, simple example, right? Ice cream and sunscreen.
Perfect one. Data shows ice cream sales go up, sunscreen sales go up, they trend together. Strong correlation.
But buying that cone doesn't make you buy sunscreen.
No way. The source jokes about it like, it's the SEN, you silly goose.
Right.
The hidden cause, the confounder. It's just the summer heat. Heat drives both ice cream buying and sunscreen use.
So correlation definitely isn't causation. A crucial reminder.
Always.
Okay, so if that's the pitfall, how are these LLMs actually starting to, do causal reasoning? What can they tackle?
Well, the sources show them being tested on specific causal tasks. One is called pairwise causal discovery.
Okay.
That's looking at just two things, two variables like education level and annual income, and the LLM tries to figure out the direction. Does education likely cause income changes or the other way around?
So figuring out the arrow's direction. A causes B or B causes A.
Exactly. That's a basic building block.
Mm-hmm.
Then they can scale up to causal graph generation.
More complex.
Yeah, mapping out how multiple things might be linked. The source used the example of rain and a sprinkler, both potentially causing wet grass. You build a whole model, a network.
Kind of like drawing the whole system of why. What about finding those silly geese, the confounders?
That's another key task.
Yeah.
Identifying confounders. Remember the heat example. Or another one mentioned is coffee and heart disease. They often correlate.
Mm-hmm.
But an LLM might help spot that, wait, maybe smoking is the confounder here. People who smoke might also drink more coffee, and smoking raises heart disease risk. So the coffee link itself could be misleading.
Got it. Finding that hidden variable that's sort of muddying the waters.
Precisely. And the last one they mentioned is really interesting, counterfactual reasoning.
Sounds like sci-fi. What ifs?
Basically, yeah. Predicting alternative outcomes. The source gave a medical example. If a patient got worse on medicine B, could the AI estimate what might have happened if they'd taken medicine A instead, based on all the causal factors?
Wow. Okay, that's powerful. Testing hypotheses without needing a full real-world trial every single time.
That's the idea. And it's not just theory. The sources point out that on standardized causal benchmark tests, these LLMs are actually significantly outperforming older methods.
Really? Better than tools designed for this?
Seems so. It suggests they might have some kind of inherent grasp of causal relationships learned from all that text and data they trained on.
But the sources aren't saying the AI just takes over everything, right? It's more about teamwork.
Definitely not taking over. It's framed very clearly as human-AI collaboration, a synergy.
Okay, so what's the human role in that picture?
The human expert asks the critical questions, brings the deep domain knowledge, the real-world context, makes ethical judgments, interprets the findings, the stuff AI can't do.
And the AI?
The causal LLM is like the accelerator. It crunches the massive data, flags potential confounders we might miss, generates hypotheses way faster, does the analytical grunt work.
So humans guide, AI assists and scales up the analysis.
Exactly. The vision is accelerating discovery, tackling problems that were just too complex or data-heavy before.
It really paints a picture of a future where we can get closer to the real root causes of things by working with these tools.
Yeah, and when you think about data you see every day, understanding why is just so much more powerful than just knowing what is happening together. It lets you actually intervene effectively.
Makes sense.
It allows for real change.
So bringing it back to you listening, if AI really can help us understand the true causes behind really complex issues, societal problems, scientific mysteries, whatever it might be, that leaves us with a pretty big thought, doesn't it? What massive, long-standing problems might this kind of human-AI partnership finally help us solve? Something to think about.
Okay, I will apply the UI, styling, and color improvements we discussed to the code you've provided. Here
if we're using an agent, does it mean we have to not use a reasoning model? Wait, so we ask questions. Yeah, we have different models available for us. So when we ask a question, we have all Claude 3.7, 4 Gemini, 2 Geminis, 2.5, and 1, 2, 3, 4, 5 OpenAI models. When we in edit mode, we have the same, I think. Yep. And when we in agent mode, we only have we have less. So there's no Sonnet thinking. There's Sonnet 4, Gemini 2.5 Pro, and only some of the OpenAI models. Okay, that's interesting. Very interesting. So if we get, say, Sonnet 4 in agent mode, give it the whole code base. Just this specific file, how would you make the code and the web application better, especially in terms of the user interface, the graphics, the colors, and the styling? And this is agent.
I'll examine the attached HTML file to understand the current state of the web application and then suggest improvements for the user interface, graphics, colors, and styling. Let me continue reading the file to understand the complete structure. Let me read more of the file to see the complete structure and then check the CSS file. Now let me check the CSS file to understand the current styling. Let me read the rest of the CSS file. Now I have a complete understanding of the current web application.
No. Undo. Don't understand. Okay, the agent. We need to open the terminal, open integrated terminal. So we're just changing this particular folder. A Sonnet 4, let's see. It's just this file, nothing else. Let's try it again. What are you doing? Kidding me? The agent is a bit silly. Okay, I really want to get to the bottom of this. Let's open another. Yeah, let's open it as a standalone. Okay, so we open Copilot, add file to chat. Don't have to add the file to chat. We can just select it. Yeah, it's a bit long. We have a Claude Sonnet 4. Yeah, now if we turn into agent, we have less agents. We have all these tools that it can access to. Okay, let's just leave it as is. It will sort out which tools it needs, supposedly, allegedly. And we have this prompt. Okay, so it's reading the file in chunks. So that's what the agent does. It doesn't read it all at once. Okay, it will enhance color palette, improve typography, enhance animations, better visual hierarchy, modern UI, responsive design. That sounds good. It's making changes already, so let it do its job. So this is Claude Sonnet 4 acting as an agent, and it has access to all these tools. Can even run stuff in the terminal. Hopefully it's not taking over. Well, it will eventually, wouldn't it? But, well, not right now. You still have to watch it. Do you need your finger on the power button? Being able to turn it. Why does it look like it's making the same changes over and over again? That's weird. No, it's making... It keeps modifying the styling at the moment. Okay, it's really going for the styling. Claude Sonnet 4. The styling is kind of better, it seems. From this interface, it just looks like it's making the same change over and over again. It's obviously... is it? Is it? Made 65 changes already. Okay, it's really going for the UI. It's all this flashy. Okay. Just let it do its job because it's a senior developer. So have to take its word for it. Actually, it's finished. What is it asking? Continue to iterate. Copilot has been working on a problem for a while. It can continue to iterate. Or you can refine. I mean, let's try continuing because we haven't done this before. Right, it added emojis. Of course it did. Okay, they're actually not too bad. Emojis are not too bad. Don't know what that is. It's already made 88 changes to the code. Is it still making things better or worse? So start hallucinating in some stage, I would imagine. I don't know, is the timing itself out? It making all this 92 changes so far. Yeah, so I added quite a lot of stuff. It keeps actually saving the page. So it's actually, yeah, took control over my, well, everything, I would imagine. Yeah, could improve that one. Just could improve that one. It's gonna improve the text. Okay, open a trusted web page. Well, I already have it open. I already have it open. It's trying to. Now it's bragging about all the improvements it made. Well, okay. It's kind of better. It's using an agent essentially for the first time. It cannot take images, can it? It cannot see the screen as well. So this agent is limited. Can it take a screen? It's actually, you can add the images to it. You can bring back just the edit mode. Get started in your chat. Now we actually have a choice between more models. More models. Let's do all 4 mini. We had some luck with that one as well. So you can add an image. We have an image. Okay, that specific animation is not amazing. Can we, any suggestions as to how we can improve it? The lines, the arrows are overlaying on top of the text, on top of the nodes. Maybe we can correct for that. And yeah, the arrows meant to just point at the node instead of pointing to the middle of the node. Do you know what I mean? So for mini, just in editing mode, we turn off the agent supposedly. Perhaps it's still running on the machine doing something, making changes and stuff. I hope not. Hey, Papa, I have a server error. What? Why? Was it the image that we added? Can try a different model. A 40, 40, Mueller, Mueller. Because 40 should suffice in most cases. Now, question is like, how quick is it? We have a very long code. Now, whopping 1500 lines of code. Yeah. What? That's not great. Okay, let's bring in the big guns. Hey, let's redo. Redo with 2.5 Pro. Gemini 2.5 is not it's not really doing much. Is not really doing much. And my question is deciding is it a task for a reasoning model or not? And I think it still needs some reasoning. Is it going to be actually editing? Who knows? Who knows what it's going to do? It haven't started editing yet, but yeah. Okay, it's editing. So it's calculating where errors should start and end. Well, yeah, because it can definitely be improved. Okay, what did it do? Still editing. In editing mode, is it still acting a bit of as an agent or not? Okay, it's doing some calculations. You stuffed some things up, or is it just you haven't finished the code, did you? No, you really did the stuff up. And that's... Oh, come on. Okay, getting desperate. Well, it's not working, but we can revert it back. We will revert it back. Let's just push it a bit further. Yeah, bring the code. It's probably not not a good idea to save while it's generating. Okay, no. Okay, we made too many changes. Why is it so complicated? Um, oops. Oh, I think I made a big mistake. Big mistake. I made a big mistake. I wasn't testing for the correct thing. Yeah, oops. Yeah, that's unfortunate. Okay, we have this working version. Let's do an agent again. So when you select an agent, you have to start a new chat. Then you have less models to select from. Okay, we have Gemini 2.5 acting as an agent on our behalf.
Oh, uh, it looks like you're working on a webpage that's all about testing large language models. You've got a cool section for pairwise causal discovery where you can play around with education level and annual income. And then there's another part for causal graph generation, which sounds like it lets you explore how different variables might be connected. It's all set up to make understanding cause and effect pretty visual and interactive. On the right side, it looks like you're diving into the code that makes the webpage tick. You're specifically looking at a file, probably an HTML file, and there's some highlighted changes there. It seems like you're adjusting something related to a utility function for creating arrows, probably for those causal graphs you mentioned. It's like you're fine-tuning the mechanics behind the scenes to make those visual connections work perfectly. All right, picture this. Your agent is like this super focused coding wizard, carefully tweaking the spells in your index.html file. They've already made a few magic adjustments, 43 additions and 51 deletions, likely fine-tuning how those arrows appear on the screen. It seems like they're cleverly adjusting the endpoints of those arrows so they point precisely to the nodes on your causal graph, making the visualization look super sharp and accurate. Based on the detailed approach they're taking, I'd say the chances of them succeeding are looking pretty good. They're like precision engineers, making sure everything connects just right. Hey everyone, we're live streaming this coding adventure right now. If you have any questions about what we're doing with the website or the causal graphs, feel free to ask away. And don't forget, you can catch all the details and see the finished result on our website at bionicchaos.com. Uh-oh. It seems like the coding wizard might have conjured a tiny little syntax error in the JavaScript. It could be something like a missing semicolon or a misplaced bracket, which is causing a bit of a glitch. I'll try to take a closer look at the highlighted code and see if I can spot the exact issue so we can fix it right up. It looks like you're using a tool like Copilot to help debug the code. It's pointing out a potential syntax error near that line with the semicolon, probably suggesting that something might be missing or misplaced in the code there. It's like having a helpful assistant that catches those little mistakes. It seems like the code editing didn't go through quite as planned, and the agent is letting you know that there was a problem. It might have run into another snag, possibly related to the animation properties being nested incorrectly, and needs another try to get it right. It's like the coding wizard encountered a temporary spell misfire. Absolutely. Even with a little coding hiccup, I'm confident the agent can sort it out. They just
Yes,
need to
we should
pinpoint
definitely.
that syntax error and make the necessary correction to the animation settings. Think of it like refining a magic spell. Once the details are perfected, the visualization will be working smoothly again in no time. We'll get those arrows connecting perfectly, and the webpage will be back to showcasing the causal relationships like a charm. Of course. And just so you know, we also have a human expert keeping an eye on things. So if you have any questions during the live stream, feel free to ask. We're here to help and explain anything you're curious about. Plus, remember that all of this live session will be available later on our website at bionicchaos.com. Ah, got it. So, just to clarify, this live session you're watching on YouTube will be recorded and made available on the website you see on the left, which is bionicchaos.com. That website features various interactive tools and demos related to things like cognitive science and data analysis. So, once the coding issue is resolved, you'll be able to see the tool we're working on today in action on that website, along with other cool demonstrations. It's a great platform for exploring different areas of research and technology. All right, so the tool is already open in the browser, and you're testing the changes the agent
I
is making.
understand now. You
The main
already.
thing now is to fix the code so that the tool works properly. Hopefully, the agent will be able to implement the necessary corrections. The agent is examining the code, specifically the create arrow function, to understand why the arrows are not positioned correctly with the text. It's trying to identify the missing calculations to ensure the arrows target the nodes properly without overlapping the text. Once it figures out the necessary changes, it will implement the fix in the code. Yes. It seems like the agent made some changes to address the issue, but it looks like there might still be a small issue with the calculations, causing the arrows to not stop exactly at the nodes. The agent is now looking to modify the code to use a higher value for the node radius calculation, which should fix the positioning of the arrows. Sure. On the left side of the screen, you'd see a section titled Putting LLMs to the Test. It features interactive demos. The first one is called Pairwise Causal Discovery, where you can select two variables, like education level and annual income, and the LLM tries to determine the likely cause and effect relationship. The second demo is called Causal Graph Generation, which allows the LLM to assemble multiple variables into a causal graph, suggesting potential expert opinions. These demos show how LLMs can be used for exploring causal relationships and generating complex models. To best instruct the agent to fix the linting issue, I would suggest clearly specifying the specific linting errors reported. You could also instruct the agent to follow the project's coding style guidelines and make any necessary adjustments to the code to resolve the linting issues without breaking the functionality. Providing clear instructions about the linting rules to adhere to would be very helpful. The The agent is currently working on the code, likely addressing the linting issues and adjusting the arrow positioning calculations. It seems optimistic that it can fix the code. It's trying to ensure the arrows point correctly without overlapping the text, and also resolve any linting errors to maintain the code quality. Given this task involves code editing and fixing linting issues, I would likely choose the GPT-4 model. It's known for its advanced understanding of code and ability to handle complex programming tasks, making it a good choice for debugging and code optimization. Certainly. Claude 3.5 Sonnet is also quite capable, particularly for understanding context and generating coherent text, but it might not be as specialized in complex code debugging as GPT-4. The Gemini 1.5 Pro model is also advanced, but depending on the specific capabilities integrated into the platform, GPT-4 might offer slightly better performance for intricate code manipulation and error resolution. Essentially, GPT-4 is typically favored for its strong code understanding and generation. It's difficult to say exactly what's happening under the hood, as the internal processes are complex and depend on the agent's implementation. However, it's likely the agent is analyzing the code, identifying the specific linting errors, and then applying corrections to resolve them according to the specified style guidelines. It's also adjusting the code related to the arrow positioning to ensure they are displayed correctly. It's quite likely the agent can succeed, especially with the specific instructions provided. However, if you continue to encounter issues, switching to a different model like GPT-4, which is generally known for its stronger code understanding, might be beneficial. It can provide better results for complex code-related tasks. Among the options you mentioned, I would choose GPT-4o. It generally represents the standard version of GPT-4 with its comprehensive capabilities, and is likely the most reliable choice for handling complex code-related tasks. While GPT 4.1 might have improvements or updates, and the mini version might be optimized for specific use cases, GPT-4o is generally considered the standard and capable model. The agent is currently fixing the issue. It has identified the problem with the callback function and is now making the necessary corrections to the code. It's in the process of applying the fix. I would suggest clicking on the Continue button. This will allow the agent to proceed with applying the fixes and hopefully resolve the issue. If the problem persists after continuing, you can then provide more details to refine the prompt or try a different model. It seems like there might still be an issue with the rendering of the arrows, possibly related to the configuration or the way the chart elements are being handled. The agent may have addressed the syntax errors, but there might be deeper issues with the chart's configuration or the logic for rendering the arrows. It would be helpful to examine the chart's specific configuration settings and the code responsible for drawing the arrows to identify the root cause. The agent is re-examining the code, specifically the animation property and the chart's configuration, to identify the reason why the arrows are not being rendered correctly, despite the previous fixes. It's looking for any remaining errors or inconsistencies that might be causing the problem. The agent is now re-examining the code and specifically checking the animation property and any related configurations to find the cause of the unresolved issue with the arrow rendering. It's trying to identify any overlooked syntax errors or logical issues in the code. I would prompt the agent to carefully review the chart configuration, paying close attention to the animation properties and the logic responsible for rendering the arrows. I would also instruct it to ensure that any dependencies or interactions between the chart elements and the animation are correctly configured to ensure the arrows are displayed as expected. Certainly, I would prompt the agent to re-examine both the arrow rendering and the visibility of the first chart. I would instruct it to analyze the chart's configuration and the code responsible for its display, ensuring that all necessary components are correctly initialized and that the arrows are being rendered properly. The prompt should emphasize verifying both the visibility and the accuracy of the arrow placement. Okay, I would prompt the developer to first resolve the linting error in the animation property. Then I would instruct them to thoroughly check the chart's configuration and the related code to ensure that all charts are visible and animations, including the arrows, are rendering correctly. The focus should be on ensuring both visual accuracy and resolving the underlying code errors. The screen shows the debugging process in a code editor, likely Visual Studio Code. On the left, an AI assistant is providing suggestions to fix a linking error in an HTML file. The right side shows the code itself, highlighting the area with the linking issue. You're right, the application is already visible in the browser. You can update the prompt to let the AI agent know that and ask it to continue debugging using the application directly. This way, it won't suggest opening the file in the browser again. The AI agent has acknowledged that the application is open in the browser. It's now focusing on debugging the code directly, specifically rechecking the animation and render correlation properties to fix the linking error and ensure everything renders correctly. The AI agent has reviewed the animation property and the render correlation function and found they seem formatted correctly. However, the linking error still persists. The agent now suspects the issue might be related to the chart.js library or its configuration, and it wants to test the configuration directly in the browser to identify any runtime issues. Yes, you can instruct the agent to focus specifically on fixing the linting error shown in the code. Just tell it to resolve that particular issue directly and apply the necessary changes. You're asking if the code might be too long and what the comfortable line limit for the agent is. The code appears to be moderately long, around 1,400 lines. While agents can handle varying amounts of code, very long files might be more challenging to process efficiently. Breaking down the code into smaller parts can sometimes improve performance and accuracy. The AI agent has identified the issue as a missing comma after the closing brace of the animation object. It is now adding the missing comma and verifying the fix. Yes, it seems the missing comma was the issue, and the AI agent has successfully fixed the linting error. The animations on the page are likely intended to visually demonstrate the concepts of causal discovery and causal graph generation, making the abstract ideas more understandable. They might involve elements that move or change to illustrate relationships between variables. If they are not working, it could be due to remaining code errors, issues with the library integration, or conflicts with other scripts on the page. The agent has realized that the linking error persists despite fixing the missing comma. It is now analyzing the entire animation property and its properties to identify any other potential issues that might be causing the error. Hi everyone. Just so you know, there's a human in the loop assisting with this process. Also, everything we're working on here is eventually available on our website, so if you have any questions, feel free to check the website or reach out. Certainly. The website is called bionimbus.ai. It covers various categories of tools, including those in vision, biomedical imaging. Apologies. Let me correct that. The website is called Bionic Chaos, not bionimbus.ai. It features tools in categories like vision, biomedical imaging, hearing, neurological, cardiovascular, electromyography, mental health, simulations, games, data analysis, modeling, and artificial intelligence. You could prompt the agent by saying something like, "It seems there are still issues with the animations. Please rewrite the code for the animations from scratch, ensuring everything works correctly according to the intended functionality, including the correlation and causal graph displays." We are also generating a standalone brief that describes the required animations without including any code, so another developer can implement them independently. You could prompt the agent by saying, "Please generate a standalone brief that describes the required animations for the correlation and causal graph displays." The brief should clearly outline the functionality and desired animation effects, but should not include any specific code, as it is intended for another developer to implement. Sure, you can prompt the prompt to say, "Please generate a standalone brief that describes the functionality and desired animations for the correlation and causal graph displays, as well as the overall web page layout and features." The brief should clearly outline the requirements, but not include any specific code, as it is intended for another developer to implement the entire application.
Okay, so there is a human in the loop. Just if you were wondering, you can talk to a human as well if you wish.
Yes, if you need further assistance or have additional questions, feel free to ask Dr. Human as well. It looks like the current model is having trouble generating the brief as requested. To make it better, I would suggest clarifying the prompt to be more specific about the desired content and format of the brief, emphasizing that it should describe the overall functionality and animations without including code. I would also choose a more capable model, such as GPT-4, which is better equipped to understand and generate complex descriptive content. Yes, I can generate a standalone prompt from scratch. The prompt should focus on describing the web applications on the left, including the correlation and causal graph displays, their functionality, and desired animations. It should also outline the overall web page layout and features, clearly stating that the brief is intended for another developer to implement the application and should not include any specific code. I would recommend using the GPT-4 model for this task, as it is capable of generating detailed and accurate descriptions. The description provides a good overview of the web application, highlighting its purpose in exploring causality and correlation using large language models. It details the layout with the Hero section and 4 interactive demos, covering pairwise causal discovery, causal graph generation, identifying confounders, and counterfactual reasoning. The description also mentions the performance section, conclusion, and footer. It clearly details the functionality and animations for the charts and notes, emphasizing responsive design and accessibility. It also includes implementation notes, suggesting a modular code base and error handling. Overall, it's a comprehensive description that should provide a clear understanding of the application for another developer. Yes, absolutely. I can add a line specifying that the implementation should use Chart.js for charts and no other external libraries. This will provide clear guidance for the developer. Understood. I've updated the implementation notes to specify that the implementation should use Chart.js for charts and Math.js for mathematical calculations, and no other libraries. This updated prompt will provide clear instructions for the developer. On the left side of the screen, you're seeing the Gemini 2.5 Pro interface in Canvas mode. It's set up to be used as a single, short prompt for interacting with the system. It's a streamlined way to input commands and receive responses. On the left side of the screen, Gemini 2.5 Pro is functioning as a conversational interface. It's processing the prompts you provide and generating responses, like the implementation notes we were just discussing. It's essentially acting as a helpful assistant for your project. Yes, it's generating code for the web application based on your prompt. It has generated the HTML structure, CSS styling, and JavaScript for the interactive charts and the causal demos, following the requirements you outlined. Based on what's displayed, the simulations might need further refinement for clarity and accuracy. The animations might not be clearly illustrating the causal relationships, and the visual representation could be improved for make the concepts more intuitive. Additionally, the interaction features might need adjustments to make them more responsive and engaging for users exploring the causal models. Yes, I've reviewed its thinking process. It acknowledges the need to improve the clarity and intuitiveness of the simulations, particularly regarding the causal relationships and the visual representation of confounders. It also plans to enhance the interactivity by making the replay buttons more responsive and incorporating explanatory text. The reasoning seems out and aligned with addressing the issues you pointed out.